All right, let's get started. Welcome everyone to our first workshop in the machine learning series. Today, our two technical leads, Hasbani and I, are going to be presenting this workshop. Um, this workshop series is going to be a three-part workshop series. Um, as you can see over here, we have the intro to Python right now. And then next week, we have the intro to machine learning workshop, which is going to be a continuation of this. And well, I guess we have the spring break after that. And the week after that, we would have implementing machine learning using classification. So we're going to be using a decision tree classifier for that. So this all sounds very strange right now, but believe me, as you work through the series, you'll understand completely what we're talking about. And just as a beginner workshop today, we're going to start with Python. So a little on what we'll be using today in terms of the software requirements. You really don't need anything to be installed. All you need to do is follow this link. I am going to put this link in the chat as well. Um, just open it up in your browser, whichever browser that you choose, and you should be good to go. So mostly what you should be seeing is something like this. This is what you should see in your browser. So this is all you need for today's workshop to get started. All right. Um, okay. So this is something called a collaboratory, what we're going to be using today. This is Google's implementation of a Jupyter notebook. So a Jupyter notebook is basically kind of like an IDE that helps you run Python in it. So usually how Python is written is in a script file, like any other programming language, right? So you have your file and then you run the file all at once. So the advantage with the Jupyter notebook is that you can kind of run each cell individually. For example, the code is divided up into each cells, and then you can run each cell individually so that it doesn't take like forever for you to run your program, right? So this is just one of the IDs that we're going to be using today. It's going to feel a bit new at first, but I'm sure you'll get a hang of it real quick. So yeah, I'll hand it over to Haswani for the Python part of it.
Hi everyone, can y'all hear me?
Yep.
Okay, I'm gonna start with introducing Python. So Python is an open source, high-level interpreted programming language, which is very popularly used for data analysis, data science, because it has like really extensive libraries with functions for it. Oh, there you go. So some libraries that we commonly use are pandas, numpy, and skitlearn. So yeah, Python is dynamically typed, meaning that the variables are bound to their types during execution. So from the little difference there is that in C++ you have to declare what type your variable is. So if it's an integer, you have to use int beforehand. In Python, you don't have to. You don't have to do that. You just type the variable name, equal it to whatever it's going to be, an integer. And then when you execute it, Python will bound it to the variable type. Another difference with Python is that it uses indentation instead of, for C++, they use like the, what's it called? They use terminal semicolon, there you go. Yeah, they use a semicolon.
Yeah.
In Python, you don't have to use anything. You just click enter and it should figure it out on its own. To import libraries, similar to C++, instead of using the include, we use import. And as I had mentioned earlier, we don't use any terminating characters for that. So we're gonna go ahead and move on to some basic data types for people that are just getting introduced to programming. And we're going to explain them right here. So some basic data types, whether it's in this programming language or any other, we have integer, which for short int, and we have a data table right here explaining the data types and how you would use them using Python. We have Booleans, which are logical operators. They use true and false. The floating points, which is decimal integers, char for single characters, and strings for a string of text characters. And these are just examples. If you also have the Colab open, we have a cell right there that you could run to see, yeah, right there. You go ahead and run it there, and you can see the output. So it prints out the actual variable, and then with type, we print out what type it is. So there you go. For 4, it's a class int. For y, it's true, and it's a Boolean. 3.7, and it's a float. And then right here, it tells you it's a class str string.
Okay, perfect. So those were just the basic data types that you pretty much have in most programming languages. If you have used any programming languages so far, you would pretty much know those. So something that is new in Python is that we have all these compound data types, namely lists, dictionaries, tuples, and sets. So I'm going to slowly walk over these with you. Lists are basically, they're mutable. Think of them like arrays in C or C++, for example. They can be changed, and then they follow a particular sequence. Dictionaries, on the other hand, they follow a key value pair pattern. These are basically hash tables, right? So one key thing in dictionaries is that the keys have to be unique. So if we go through this example, here we have defined an int list. So this is basically a list of numbers. You can have a list of strings. You can have nested lists. You can have lists of different data types, so on and so forth. So there is a lot of variety, and you can do a lot of things with lists. Uh, One of the most common things to do is get the count of the items in list. So here you can see if I type in .count, it will give me the count of uh, the item apple in the list. So you can see that apple appears here twice. So that's why the count is 2. Same goes for this. And then if you want to find out the index of particular item in a list, so you can put a dot index and you'll get the index of the item. So a list does come with a lot of inbuilt functions, which is true for most Python data types as well. Um, Right. So if you want to hop on to the notebook real quick. So over here, you can see that this kind of works with the int list that we talked about right now. And there are like so many functions, right? Methods that are already built into the data type. This just gives a few of them. So for example, the range, right? So it gives you the range of the list. In order to add a new item to the list, we use the dot append method. So as you can see over here, it inserts 11 to the list, right? So this is our original list, and then it adds 11 to the end of the list. So similarly, the pop method is going to pop an item from the top of the list, which is going to be the last item. So, and then it returns the popped item to you as well. And so on and so forth. So you can see that there are a lot of methods that are associated with each data type. I'm going to quickly hop over to a dictionary. So a dictionary, like we discussed, is a data type that stores key value pairs. So how does this help us? So for example, you want to look up somebody's phone number, right? So you put in the key would be somebody's name, let's say Jack, and then the phone. Well, this does not look like a phone number, but then it would be like typically like this, right? So it would be a phone number. So likewise, if I want to access somebody's phone number, I would just type in, uh, I'm sorry. So the name of the dictionary and then the name of the key within brackets, and then this should give you the phone number for this particular person. Okay. Similarly, if I just type in, if I want to print out the dictionary as well, I can see the entire contents of the dictionary over here. So again, if we want to quickly hop on to the notebook, you can see over here that there is a dictionary called abbreviation. It stores in all the state names. And then if I so again, like even dictionary, it comes with a lot of inbuilt methods. For example, print would just print in the dictionary itself. I'm sorry, that's not a method, but um dictionary dot keys will give you all the keys in the dictionary. So over here, you can see that we created a dictionary using these curly braces. And then this is how we assign a value to a particular key. So for example, the key MI is assigned the value Michigan. So one thing to note here is that assigning values to a particular key in a dictionary is not limited to strings. This could be any complex data type. It could be a dictionary in itself, right? It could be a list. It could be anything. So it does offer a great flexibility in that sense, especially in terms of dealing with data. You can store any type of data in it, and then you don't have to worry about the type of data. So that is something that we want to come back to regarding Python, is that you don't declare data types at compile time, like has been discussed in the beginning. So that's one of the advantages as well. In terms of, yeah, so the next data type we want to discuss is a tuple. So um, a tuple is basically an ordered sequence of elements. They are different from a list in the sense that they cannot be muted, they cannot be changed later on, right? Um, we can see an example over here. Right, there you go. So it pretty much looks like a list, right? But it is not, because the fact is, well, I can print the element in the tuple over here, but then I cannot change it. So if I go over here again, so as you can see here, I've defined a couple of tuples, right? And then if I try to change a particular value of a tuple, this will throw me an error. That's simply because tuples are immutable. So when would a tuple be useful for you? For example, tuples are useful in the case when you want to declare something that has constant values, right? Um, okay, hopping on to sets. So sets are kind of, they work like dictionaries, but then they also support mathematical operations like intersection, difference, and so on and so forth. So like over here, you print in the set, and then you can see, well, I did not demonstrate how you can do difference and all, but then you can pretty much get an idea of um, how sets work, and then you can put in items into this set as well. So hopping on to arithmetic and math modules. Um, so the basic use of Python is, of course, one of the major uses is for machine learning, right? So machine learning does involve a lot of math. Um, Now we have the math module over here, which has all the basic functions like square root, power, exponential, logarithms, and so on and so forth. If you go over here, um, so this file kind of gives you an idea of how all this works. algorithm, the arithmetic functions work. So for example, if I go in here and then I print it out, so it will give me the power function and then the round. So power is basically if you want to do a square of a particular number, right? So that is basically what it is doing over here. So Z6, for example, over here, you have the value of Z is 3.7 and it's gonna print out the power of 3.7 raised to the power 2. Okay. Similarly, the math module, again, it provides so many different things. You have square root and then seal, floor, so on and so forth. So again, if I go through this real quick, you can see a number of things that the math module does, right? So, okay, moving on, the string and Boolean operations. Again, just like any other programming languages, you have Bool operations and string operations in Python as well. The way we deal with logical operations, well, you can simply run this and then find out. We have 3 logical operations: and, or, and not, that are supported here in Python. Um, String manipulation, when do you need to use string manipulation, right? So sometimes you want to get a part of a string, you want to change it to uppercase, lowercase, all sorts of things, right? So this is where the Python's string manipulation comes into the picture. All right, so I'm gonna hand over to Hasbani.
So for the next section, we're going to talk about control flow statements. So this, what it basically is referring to is if statements, for loops, while loops. So we go ahead in the next slide. So right here, for the very first one, we're going to talk about the if statements, which are pretty similar to C++ and other languages. The only difference is the syntax here. For the else if, instead of actually typing else if, you use elif. But other than that, they work similar. They work the same way. So they're used to make decisions. They're used to make decisions on how you want the program to run. They're similar to the switch or case statements that you would find in C++. And right here we have a little flow diagram of how it works. So you go ahead and you start with a conditional statement, and this will either return true or false. If it's true, it goes ahead into the first statement, statement 1. If it's false, it goes ahead and tries elif. It checks that conditional statement. If that one returns true, it would then go into statement 2. But again, if it returns false, it goes into the very last one, else, and it returns statement 3. And that's how the little function here on the if statements go through. I think we have on the Colab, we have some code on there too for it. So yes, if you run here, we're using right here on the very first one, the conditional statement is x module 2, which is getting the remainder of, it's checking if it's even. There you go. And if it's even, it goes ahead and prints x is even. If it's not, then it goes ahead and prints x is odd. For this one, it should print, there you go, x equals 10 is even. And then it goes to the other if statement down here, checks it if it's positive or negative. And here we're using elif as well. So if it's less than 0, it goes ahead and checks if it's negative. If it's greater than 0, it goes ahead and checks if it's positive. And if we had some other number besides 10, it would go into the else statement right here. For the next control flow statement, we have our for loops. So for loops, they are similar to the ones in C++ and other programming languages, but they're just used a little bit different. So what we're used to seeing is the user usually controls the indexing when you use for loop. So you do int I, and then I is less than some parameter, some number, and then you do I++, right? For Python, it's different. We have what is called the in operator. And as you can see here in the flow chart, you say the for iterating variable, which could be the list, tuple, whatever you're iterating through, and then is in the sequence. So you go ahead, let me see, go ahead in the collab. So right here we have some examples of the very first one is a list. So while we're using the for loop, you would do for word for each word in the list, in my list. You would go ahead and replace is with at. So it's gonna go ahead and replace the second item there, the second element with at. And if you go ahead and run it, that's what it should happen. Oh, there you go. That at a. So as you can see here, instead of actually indexing and using I is less than or increasing the counter I, you go ahead and just use the word, the keyword there in. So we have a question here. Where do you define the word variable, or is it defined within the loop? So yeah, it is defined within the loop. You don't have to previously define it anywhere. It's a keyword that you're gonna use. So for, I could change it to anything else, and it should work the same. Python automatically assumes that you're referring, that you're gonna use that to iterate through the list. And then if we go for the third control flow statement here, we're gonna use, these are while loops. The while loops are similar to other programming languages. So it's a conditional statement right here. If it holds true, it keeps looping. Once the statement is false, it could go ahead and exit out of the while loop. And we also have some examples there on the collab. So right here, so right here for the very first one, list range, it goes ahead and while the list index is less than 0, it goes ahead and adds the index. And as you can see right here at the very bottom, it prints it out. While we use right here on the second while loop, this one uses an else statement as well. You can add else statements on the while loops. So once the while loop reaches the condition statement to be false, it goes into the else statement and prints out whatever you put into there. So for right here, we have the count is set to 0. So as long as the count is less than 5, it's gonna go ahead and loop and it's gonna print out less than 5. And of course, to avoid having an infinite loop, you have to increase the count so it eventually reaches the number 5 instead of staying there forever. And once this count becomes 5, this becomes false. 5 is not less than 5, they're equal to each other. So it goes into the else portion of it and prints it out.
All right. Yeah, I think we are all the way to functions now. So user-defined functions in Python pretty much work similar to other languages. The only, I would say the one cool thing about Python in terms of functions is having unnamed functions or lambda functions. So what I feel is it's kind of like a shorthand way of writing your functions down. usually a bit more advanced coders do use that. So for example, in this lambda function over here, you can see that I have named my function, and then so the arguments that go into the function are defined over here, and then the assignment is done over here. So when I try to run this function, this will give me the value over here. So for example, I pass the value 2 into this function. This function takes in the value 2, and then it processes it in using whatever is after the semicolon over here. So it's gonna do all sorts of math, and then just print out 11 over here. So this is something different that you don't find in other languages. And in terms of a traditional function, for example, we have defined a function called discard over here. Basically, what it does is it discards missing values from a list. Um, so this function definition, the way we write it is we use the keyword def over here, and this is the name of the function, and this is the argument list for the function, and then it always by a semicolon. I'm sorry, a colon. So this colon you might have observed somewhere before also. For example, when we defined if-else statements, right? Um, and when we define for loops, so there are very specific places where this colon is used. So a function definition is one of the places, of course. Within this function, we have defined a list. In this list, we are iterating over the list, again, the for loop from before. Um, we are using the math library over here, the math module. So one way to import modules in Python is simply you type in import the name of the module, quite similar to Java and all the other languages, right? So the dot notation again is used to kind of access the methods within a module. So mat dot is nan is gonna tell me if this particular item in this list is a number, is not a number, right? So it checks the type of the item. So next, the out list is the output that I'm going to send. So which we declared over here as empty. We append a particular item to the out list if it is not a number, right? Or well, not a number is in essentially meaning to say that the value is null, right? And then we saw if the sort flag is set to true, the list is sorted as well. And then finally, we return the out list to the sorting line. So for example, here my list is the variable which will kind of store the output, the result of this method call. Um, and then once I print it out, uh, it's I'm sorry, the method call happens over here, and then I can print out the result of this method called over here. I'm sorry, that was my bad. This is basically the list that we defined. And then here we're doing the method call and then passing in the list, and then it sets the sort flag to true, which means we need to sort out the incoming, the out list, basically the output. And then this is the result that you get. So the main idea of this function was to kind of remove these nan values, right? So, and then since we set the sort flag to true, it will sort the items as well and then return it to this one. So here, for example, what I was talking about earlier, let's say I was to store this result into a particular variable, and I did this, and then if I did this, this would basically give me the same thing, right? So I'm just assigning this to a new variable, right? So functions in Python are a very useful way to kind of create reusable code, of course. Um, and then it also kind of helps you to organize your code as well. All right, hopping on to file input output. So in this, we kind of have a file over here, which is states.txt. And then if I can show you the contents of the file real quick. All right, there you go. So this file, basically, it contains a bunch of lines in it. So one very common thing that we would have to do, especially when we're dealing with machine learning, right, is to do a lot of reading of files. Usually the files are in CSV format. This is just an example to show you how it works. Of course, there are much more sophisticated libraries such as pandas as well, which do the job much more easier for us. But just for the demonstration, just for the sake of looking at how file input output really works in Python, um, we kind of define this line over here. So this is basically used to open the file, right? This method is used to open the file. Um, in this method, you send in the name of the file along with the mode in which the file is to be opened. So there are multiple modes. You can have read mode, you can have write mode. So of course, the difference between the two is in read mode, you cannot make any changes to the file. In write mode, you want to add something or modify something to it. So again, so if I try to run this, you can see it does all sorts of things and then it gets the input from the file. And over here, when I say R means for read mode, is it's basically reading every line in the file. It's going to collect the fields. Each line in the file is split using the comma separator. And then each field is stored in this variable. And then, so as you can see, this particular file is very similar to a CSV file. Um, each one of these items are separated by a comma. And so this fields, remember, Python is not a typed language, so you don't have to set any data type over here, right? So once I kind of do this, yeah. So fields, basically, it kind of turns into a list over here. And then this list is going to contain individual items from this particular line. So, and it's going to iterate over each line from this and then print it out over here. So finally, you have to call the file.close method, just so you know none of the other functions are messing with the file, to make sure that. Um, yeah, so that was pretty much about file input output. Uh, okay, I'm just catching up with the chat right now. Uh, oh, okay, all right. So yeah, moving on. Right. So a couple of concepts that we wanted to touch on today. Uh, these are some things that you will run into very quickly once you start coding in Python. So the very first thing that I wanted to talk about today is a concept of deep copy versus shallow copy. So in Python, whenever you are assigning a variable to another variable, um, for example, let me type it out here. Let's say I have a list, right? And then the list has this many items, okay? So This is basically going to print out the list. It's a shorthand. Now, if I kind of do this, I copy the, if I want to copy this list into another variable, right? So maybe I want to keep this list as it is and then manipulate it and then, you know, have the new list as, I'm sorry, not change the original list, right? So you want a use case wherein you assign list one into list two, do some sort of manipulation in list two, right? So for example, if I say list two, I'm sorry. If I change the first element of list two to, let's say 99, and then I print out list one and list two. Let's see what happens. Right, so over here, it's basically creating a deep copy for you. How is that? Oh, I'm sorry. So what happened over here is, as you can see, when you modify list, supposed to be a copy of list one, the value in list one also gets modified. So this is some sort of a behavior that you were probably not expecting to happen, right? Because you changed list two and not one. So this concept is something called a shallow copy in Python. A shallow copy is basically, oh, I'm sorry, over here, you're basically referencing the list with a new variable. So here, a new list is not getting created. You're just referencing to the same list in memory using a new variable. So it's just a name for the same list. All right. So to kind of avoid this kind of a situation, there's a concept of deep copy. What deep copy really does is it's kind of going to create a separate list in memory for you to access. And then it returns the reference to that list to the new variable you just created. So over here, for example, if I get back to this example, so in order to achieve this, Python has an inbuilt modifier called copy. If I run this, okay, yeah. So if I run this, I can see that the contents of, let me just type it in. All right. So you can see all the values are the same, right? Because we just pretty much created copy of the original list. But the difference between a deep copy would be quite evident over here. So yeah, so for creating a shallow copy, first of all, this is the method that I use, dot copy, and for deep copy, dot deep copy. Nothing surprising over there. When I try to run this, as you would expect, creating a shallow copy would change the original list as well. So you can see the list one is also getting manipulated or changed over here. Whereas when I try to change the value of a deep copied list, which is list three, right? The original list kind of remains the same. Talking about variable scope. Okay, cool. In this, we are going to make use of functions to kind of show how variable scope works, right? Basically, there is a keyword called global in Python, which you can use to access the global variables. So a global variable is going to look something very similar to like this. So the variable A over here, which is defined outside a particular function, is a global variable. The same variable, let's say A over here, if it is defined within the scope of this function in this particular context, this function is local to this method, the function. I mean, this variable is local to this function. Okay, so what is really happening over here, right? So if I run this function, it'll be clear in a second to you guys. All right, so the value of the global variable is 1. When I am inside the function f, it's pretty much printing a global variable. When I'm inside the function g, it's immediately the variable that this accesses, even though the name of this local variable is the same, it's still going to access the local variable and print out the local variable. In H, however, there is a slight change. So as you can see over here, so let's say we print out the global variable over here, right? No surprises there. And then I call the function f. So within f, we are printing a. So a in this scope, because there's no other a variable defined within the function f, it's still going to print the global a that was there. So you get the value 1 over here. Again, the value of the global variable a is not changed because we didn't do any changes inside it. So now what happens when inside the function g, I call g here, right? And then I assign 2 to the value of a. Now, if I try to print out a, of course, this is going to give me 2 because it's referencing the local 2 here. But what happens if I print the global a again, right? The global variable a, you can see that this value has not changed. So this value remains as it is. So this is another kind of a problematic area that you might run into very quickly. So in order to access this global variable, right, you need to declare it here first. This is not the same as declaring a variable itself, but you're just kind of referencing to the global variable that you created over here. Okay, so now when you try to assign the value 3 to this a, in this case, now Python interpreter kind of knows that, okay, you are referencing to the global A that was over here. Okay, so once you do that and you print out the value of A, you can see that once it's inside H, it's 3, because of course this was supposed to happen just as the previous example. But then over here, when I try to print out the global value of A, I mean the global variable A's value, then you can see that also got changed. So this is one thing that some people might miss. Initially, you're not get like, hey, what's happening? I tried to change it here, but then it's not reflecting anywhere, right? So this is another thing that kind of we wanted to discuss today. Yeah, I think that is all we have for you today in terms of the basics of Python. Feel free to open your camera or mic and ask any question or type it in the chat, and we'll try to answer you.
I just want to say that the variable scope, that is such a, I want to say, underestimated problem issue that people don't really take account of. But yeah, it's a very important concept, because if you try to reference, for example, here, if we didn't have the global A set, we would get errors, and they're kind of funky errors. So it's best to, make sure that you're understanding the local and the global scopes. Because I know for a fact right now, I'm dealing with some issues like that with some variables. So that's why I'm like, it's a very important concept to take into consideration when you're learning it. But yeah, if anyone has any questions, otherwise, I think we can move on. We added on the slide some resources as well. There you go.
Oh, okay, yeah.
Yeah. We added some
Awesome.
additional. The Python documentation is really well, like, for learning it. It's very easy to understand. So if you guys have any questions about anything, it's gonna be a lifesaver.
Just to quickly show you all, this is pretty much what the Python library looks like, and they have a really cool tutorial here as well. So if you have the time and the interest, feel free to go through it. Yeah. Yeah, and then there is a mock online coding assessment available on Hacker Earth as well. So this is from my personal experience. I recently attended interview prep workshop somewhere. So they kind of stressed on kind of having these kind of assessments so that you can show your skills on your resume. Um, and yeah, finally, we have a Python cheat sheet available on this link. So after this workshop, we're going to post all these links on the Discord as well, just for your reference. Um, yeah, a quick recap on the upcoming events as well. So this is a three-part machine learning series that we're doing. We started with today. We are done with the introduction to Python. And I would still urge you all to kind of put in any questions that you might have onto the Discord channel that we have, so that you can type in your questions, even post workshop, anything you want help with, something new, a new concept that you want to learn, or anything at all, okay? The next workshop in the series is going to be getting started with machine learning, which is next week on Friday. Um, and then the third is we are going to discuss a single machine learning algorithm. We are going to do a project in that, start to finish, like from all the way from the basics and all the way to the finished project. Okay. So the getting started machine learning again is next week, same time, 5 p.m. Friday. And the next workshop, the final workshop in the series, is on March 26th, 5 p.m. again. Hope to see you all there again soon.
So we have a question here. Do we need to know anything else in advance besides Python for the machine learning portion? No, we're gonna teach you everything on the second workshop that we're gonna be using from the libraries that I mentioned in the beginning, pandas, numpy, how to use all of those. And it's gonna be like a very intro to machine learning, the second one. Once we get to the third one, we will be building a project, so we could have something you guys could code it out yourselves and get more experience on it. But no, for now, you don't need anything but some Python knowledge that we just introduced today.
Awesome. So the way you can keep in touch with us is register for upcoming events on the DSC-UTRGV website, become a member on V-Link, and follow us at DSC-UTRGV. Here is the link to join our Discord. I'm going to pause for a few seconds just so that you can open it up. And the best way to keep in touch with us and to keep up to date with the latest events that we would have is Discord. So make sure you join Discord. And all right. Thank you. Thank you everyone for coming in today. Thank you for your time.
Thank you.